Good morning. Welcome back from spring break. I'm sorry that I'm not here today, but we're going to keep on going. The goal is for us to have our our last test actually, next Thursday. I don't want to waste today, so I'm going to sort of talk through some of your notes with you. Hopefully, this will give you a good introduction to probability. And when I get back tomorrow, we will be ready to hit the ground running. So you should have a Coral packet. You should have gotten that from Mr. Vaughn. And I want you to take a few minutes. He's going to pause the video, and you're going to work on the problems that are on page 1 to see what you already know about probability. You probably can answer all of these questions. I'm going to go over them quickly in a few minutes after you've worked on them. And then we're going to start our notes, which will be on page 2. But right now, I want you to pause the video for about 10 minutes or so and see what you can do about answering these questions that are on page 1. Okay, let's see how you did. So when we're talking about probability, I hope that you know or what you know so far is probably that it's the chance that something's going to happen. Like the probability of it raining is a 50% chance of rain. Or if you've got 3 marbles and one is blue, one is red, one is green, what's the chance of you pulling out the green one? Well, it's 1 in 3. So it's how many of the option you're looking for do you have divided by how many total options are in that set that you're looking at. So when we're talking about the probability of choosing a king from a standard deck of playing cards, well, first you need to know how many cards are there in a deck. Well, that would be 52. And what's the probability of choosing a king? Well, how many kings are there? And there is 4 kings in a deck, and if we divide that by 52, that will reduce to a 1 in 13 chance that we would choose a king from a standard deck of playing cards. We want to make sure that we reduce probability. So if you can't do that in your head, you've got calculators, use that tool to help you. Okay, so number 2, what is the probability of choosing a green marble from a jar containing 5 red, 6 green, and 4 blue? Well, again, it's how many of that particular option do we have. And since we're talking about green marbles, we have 6 of those, divided by how many total marbles are in the jar. Well, 5 plus 6 plus 4 is 15. And if we reduce that, we have a 2 in 5 chance. We can also change these to percentages if we want to, but most of what we're going to be working with in this unit are going to be fractions. Okay, for number 3, what is the probability of choosing a marble that is not blue in problem 2? Well, if we don't want blue, that means anything other than blue would work, so that would be red or green. And there are 5 red and 6 green. That's a total of 11 not blue marbles, still divided by our same total, which is 15. That can't be reduced, so that is where we're going to stop our probability right there. What is the probability of getting an odd number when rolling a single 6-sided die? Well, on a 6-sided die, you've got 1, 2, 3, 4, 5, 6, and 3 of those numbers are odd, 1, 3, and 5. So we've got a 3 out of 6 chance, which will reduce to 1/2. Number 5, what is the probability of choosing a jack or a queen from a standard deck of 52 playing cards? Well, there are 4 jacks and there are 4 queens, so there's a total of 8 options that we can consider. There's still 52 cards in a deck, so that's our bottom number, and that will reduce to 2 out of 13. How are we doing so far? Hope we're doing great. I'm sure you are. So let's keep going. What is the probability of landing on an odd number after spinning a spinner with 7 equal sectors numbered 1 through 7? Just a side note, that equal part is important. If one sector was bigger than another, then our probability process wouldn't be able to work because you'd have a better chance of landing on the bigger sector. So we're glad they're equal. But again, we're talking about odd numbers, so that would be 1, 3, 5, and 7. So there's 4 odd numbers in those 7 numbers that we're considering. What is the probability of getting a 7 after rolling a single die numbered 1 to 6? Well, the number 7 isn't on a 1 through 6 die. So that's a 0 out of 6 chance. We're not going to get a 7. Another way that we can write that is with something called the empty set symbol or the null set. And I'm on my laptop, so this probably isn't going to look good. But it is a circle, maybe a circle. Pretend that's a circle with a line through it. There's no chance of that happening. If you look over on page 2, it's actually the last symbol on in the chart there. So that's a better picture than what I just drew. Okay, number 8. What is the probability of choosing a queen, a king, or an ace from a standard deck of playing cards? Well, we've got 3 options here, and we can choose any of them. So we've got a queen, there's 4 of those, a king, there's 4 of those, and an ace, there's 4 of those. So that's a total of 12 out of our standard 52 card deck. And if we reduce that, that will give us 3 out of 13. That's the probability of that happening. What is the probability of choosing the letter I from the word probability? Well, how many I's are in the word? 2. And how many letters are in the word itself? That's 11. Again, 2 over 11 can't reduce, so we're finished. And 10, you might not have known how to answer that. What it's asking you for is, what are my options if I'm looking at the word probability? Or like for number 8, what are my options for choosing something out of a standard deck of playing cards? And I need you to list all of those options for me. The way we're going to do that is with curly brackets. And so we're going to have our curly brackets, and we're going to list each element separated by a comma. Okay, now B actually occurs twice. We don't need to list it twice because the sample space only needs to have it once. Sorry, totally lost my train of thought there. But we don't have to list the B twice, just like we're not going to list the I twice. L, T, and Y. So those are my options for choosing letters. Now up on number 9, we still count the 2 I's and still count the 2 B's because that's how many total letters are in the word. But if I'm listing out the sample space and how many options could I choose, I can only choose one B. B's aren't different from each other. So that's where we're going to differentiate there. We got to make sure when we're listing our options, we only list the options once. But we do count the total number of those options. Okay, so if you have any questions about any of those that I just went through, ask Mr. Vaughn to pause the video so that you can or go back and re-listen to it or ask a neighbor for some clarification. But hopefully those were kind of straightforward based on what you've already learned about probability in middle school. Okay, when you're ready, we're going to move on to page 2. And you've got some notation here. Notation is really important in math. We've talked about that. And it's going to be really important in probability because most of the time these symbols are what are going to be in the problem. You're not going to have the words. You're going to have the symbols. And you're going to have to know, well, what does that symbol mean so that you can actually answer the problem. Again, up here, we've got that we're going to use our curly brackets. So we want to make sure we're doing that. Let me get my highlighter out. We got our curly brackets. So that's important. And then these symbols are important. We've got A equals B. Set A intersects set B. Those are the elements that they have in common. When they intersect each other, it's like when 2 lines intersect, it's where they cross, they have a point in common. Well, when sets intersect each other, it's the things they have in common. This is set A unioned with set B, and that's where we join the elements that are in set A with the elements of set B. So it's not the ones they have in common, it's just any elements that are in one or the other. Could be in both, But if it's in A or it's in B, it gets to be in the union of A and B. This little tick mark up here, that means not. It's really easy to miss that when you're reading problems. I miss it a lot. But this says the elements that are not in A union B. Not. So I don't want elements that are in A, and I don't want the elements that are in B. I want elements that are not in either one of them. This other weird looking symbol, this E, that means element. So this element is in set A. This element is not in set A. That's how we're going to talk about what's in a set or what's not in a set. And then we have this sort of sideways U. That says A is a subset of B, which means that everything in it that's in A is also in B. So B is bigger than A. It's got some things that A doesn't, but everything in A is also in B. And then we have our empty set. There's nothing there, like rolling a 7 on a dice. That's not going to happen. So it's an empty set. We cannot create that set of options. Okay, now let's try some. We will go back over these tomorrow, but I want you to do your best to fill this in so that you know where your questions are and what you understand and what you don't. So we're going to be working off of this spinner over here. This is going to be our example for every single problem. And Joe and Sarah are playing a board game with this spinner. Each section of the spinner has a number, 1 through 4, and it has a color, red, yellow, green, or blue. So I want to know, how can I describe A? It's the subset A of the sample space. The sample space is our spinner that describes the spinner landing on a blue section. So we're going to call this A. We're going to use our notation, and we're going to create our subset using curly brackets. We have to use those curly brackets. So we're going to look over here and find all of the options that are blue. Has nothing to do with the number. We're just looking for the ones that have blue in them. So if we start over here on the far left, we have a 3B that's blue. If we keep going around, we come to a 4B. Keep going around, we have a 2B. We have a 1B. And that's it. Those are all of the options that have blue as part of them. We didn't care about any of the other colors. And we carried the number with our elements, but that didn't matter when we were picking them. We were just looking for the blue. Okay, so subset B. Subsets use curly brackets. And this time we're looking for everything, any X, any element that has a number 3 with it. So if we start back over here with this 3B, I'm going to highlight that so we know where we're starting. This is our starting point every single time. So we've got 3B. It's a 3 in it. So we're going to keep on going around looking for 3s. Got a 3G. Keep on going around. We've got a 3Y. We have another 3Y. Do you think we have to write that again? Hopefully you said no, even though you probably think it's dumb to answer me when I'm not there. But 3Y, we don't need to say that, list that again, because it's already listed as a member of the set. We do not want to repeat elements. Okay, subset C is talking about anything that is a primary color. Well, do we remember what our primary colors are? Our primary colors are red, yellow, and blue. Those are our primary colors. So we're only going to be looking for elements that have those colors on them. Let's see, where can that go? Put it right here. Primary colors are red, yellow, and blue. So we don't care anything about green. That's really the only one we're going to ignore. But again, we don't want to repeat elements, so make sure that we're paying close attention to have we already listed this before. So 3B is a primary color. Green is not. For Y, 2 red, 4 blue, not 3 green, 2 yellow, 1 red, 2 blue, not 4 green, 3 yellow. We've already listed 1 red, so we don't need to do that again. 1 blue, not 2 green. We've already listed 3 yellow. We don't need to do that. Have we listed 4 red yet? Nope. So that is going to be our subset of the primary colors. Everything that had red, yellow, or blue. So this isn't really hard. You just have to make sure you know what you're looking for, what this element means. Okay, D, we're going to look at what subset describes landing on an odd number. Well, we know our odd numbers, 1, 3, 5, 7. But on this spinner, it's just going to be 1 and 3. So we just care about 1s and 3s. Again, we don't want to repeat, so we got to be careful with that. So starting at our 3B, that's an odd number. 1 green, not 4 yellow, not 2 red, not 4 blue. Put 3 green, not the 2. We've got our 1, not the 2, not the 4, but the 3. We already have 1 R. We don't need to repeat it. 1 blue, not the 2. We already have the 3, 3 yellow, and so we don't. And 4R is even. So this is the subset that describes landing on an odd number. Doing okay? We're almost there. You can make it. So subset E of the sample space, in terms of A and B, describes the spinner landing on a blue section with the number 3. So now we're going to start talking about combining. So we want to know A intersect B. If we look back at our chart, go back a page, the intersect is the elements that they have in common. So if we look at A and B, do they have any elements in common where they overlap each other? They both have a 3B, but that's it. These other B's are not down here in subset B. So when we're talking about where they intersect each other, trying to create set E, E is only going to be the element 3B. E is 3B. It just has one element, and that's okay. That is okay. Subset F describes the spinner landing on a primary color with an odd number, so where C intersects D. Looking at these two subsets that we've already created. Where do they intersect each other? We're going to call that F. And we're just going to go down our list. They both have a 3B, so that's one of their intersections. They don't both have a 4Y. They do not both have a 2R. They do not both have a 4B. They do not both have a 2Y. They do both have a 1R, so that's something they have in common, so they can intersect. They do not both have a 2B. They do have a 3Y, so we're going to list that. They're intersecting there. They have those in common. Do they both have a 1B? Yes. 1B. And they do not both have a 4R. So there are 4 elements that subset C and subset D both have in common. Because again, if we think back to our chart, that upside down U means intersect. Where do they intersect? What do they have in common? Okay, now G is just wanting you to generalize. If I ask you, how do you create a subset that describes the spinner landing on any particular color and number combination? What are you asked for? Well, the way that I there's the bell. It's 11 o'clock right now, according to my clock, but that's because that's what time I'm making this. How do we generalize that subset? And the way that I wrote it is that this subset is the intersection of a set with a specific color and a set with a specific number. So if I want to create a subset that describes landing on odd blue or yellows, well, I need all my odd numbers, then I need all my blue and yellows, and I need to see where they intersect each other. It's the intersection of a set with a specific color and a set with a specific number, and where do they cross each other. And then the last one that we're going to do, and then you've got some to practice for homework, is which of the sets described in part G are empty. So what specific colors and numbers don't actually have an intersection? We have to go back to our spinner for that, and we're going to have to check pretty much every color. So if we look at our blues, which we already did that, we have a 1, a 2, a 3, and a 4. So it's not blue. Blue goes with every single number. Let's check our greens. We have a 1 green, a 3 green, a 4 green, and a 2 green. So we had 1, 2, 3, and 4. Why don't I mark these, especially with me not being there? So for the blues, we had our blues here. We had all the blues. We had all the greens. 1, 2, 3, and 4. Let's check the reds. We have a 1 red. We have a 2 red. We have a 4 red, and we have another 1 red. So what red were we missing? We didn't have a 3 red. So if we were to write that out, a number 3 intersected and a red is empty. And I'm going to have to draw that out with my marker because I don't have that symbol. But a number 3 and a red, that set is going to be empty because we didn't have that. And then if we go back and check our yellows, we have 2 3s, we have a 2 and a 4. So we're missing a 1. So that's going to be another empty set. Number 1 and yellow is an empty set. So there you go. I want you to try your homework. I know that I wasn't here to answer questions, but I did my best to explain this pretty well. I hope that it made some sort of sense. And I want you to try your homework and do your best that you can. It is the 7 problems that are on the back of page 3 there for you. Look back at your chart. Think about what these intersections and unions mean. We will go over the notes tomorrow. We'll also go over the homework, and if that's all we get through tomorrow, that's fine, but at least you kind of got your feet wet with it. Thank you for behaving. Thank you for doing what I expect you to do. I appreciate it, and I will see you tomorrow. Bye.